Yes, hello there. Let me share my screen. I think I can do that now. Okay, that should
Perfect.
work. Hopefully, yes. Okay, so thank you very much, Mary Chantal. So I hope everyone can see. So what I'm going to be doing the next short while is try to give you a brief tour through some of the challenges and opportunities in relation to coastal and river resilience in Canada. So first, I'd like to look at some of the key drivers, I guess. So first one's here related to global warming and climate change. So we have things like rising temperatures, rising sea levels, changing patterns for storms and precipitation. We have ice regimes in the rivers and lakes and along our coasts are changing. And then we have other drivers, things like increasing urbanization, population growth, economic growth, global trade, environmental stewardship, and kind of emergence of quite a few new technologies as well. So now let's look to some of the top Canadian climate change risks. So I pulled this information from a recent study that came from the Council of Canadian Academies. So they were tasked to kind of review climate change risks facing Canada. Here are the top 6 risks that they highlighted in their report. So you can see we have risks to physical infrastructure from extreme weather and flooding, risks to coastal communities and infrastructure from inundation, erosion, saltwater intrusion. We have risks to northern communities, infrastructure, and livelihoods due to factors like permafrost thaw, reduced sea ice cover, and increased risks from marine accidents. As there'll be, we're seeing a growth and increase in marine traffic in the north, and so there's going to be more a likelihood of more marine accidents there. Fourth one is risks to human health and wellness caused by things like extreme weather, heat waves, lower air quality, and new pathogens. Perhaps I don't need to speak any more about that. Risks to ecosystems and species is among the top 6, and also among the top 6 risks faced in Canada are risks to the fisheries, to the factors like changing marine and freshwater conditions, ocean acidification, and invasive species. So next, I'd like to look specifically to the coastal regions in Canada and some of the main challenges that these regions face. So we have escalating flood risk along a lot of our coasts. So how do we manage and to control this? Same with erosion. So we have increasing, erosion risk. So how do we manage and control the risk of erosion? We have a whole bunch of ice-related hazards, I guess, along our coast, and these are changing as well. We have coastal and port infrastructure. We need to strengthen it and make it resistant for the future. We want to promote healthy and diverse ecosystems and species. We need to preserve healthy fish stocks. We want to do all this while we also support population growth, economic activity, and the prosperity of our nation. And lastly, but perhaps not least, how to manage and adapt to climate change. Yes, on the river side, you see some of the same challenges here, but there's a couple of new ones as well. So the first one, we have the increasing flood and drought risk. We have ice-related hazards again, strengthen and to future-proof infrastructure. Again, promote healthy and diverse ecosystems and species. New one in the river is to protect freshwater quality is really important. Again, support population growth and prosperity. A new one I put in the rivers here is kind of manage conflicting stakeholder needs and also manage kind of shared responsibilities between various parties. So there's a lot of different parties that kind of share responsibility for management, and it's important to be able to kind of manage that shared multi-party responsibility. And lastly, but perhaps again not leastly, how to manage and adapt to climate change. Okay, so now I'd like to turn and spend a bit of time looking at potential technical solutions that can be applied and brought to bear to kind of face address some of these challenges. So I have a list here. First one being better forecasting and prediction. So if we can have better advance warning of when some like a flood risk is going to occur, that will help us reduce its impact. Second one is the whole general class of better modeling tools and capabilities here. So I include here things like experimental modeling in the lab, computational fluid dynamics, application of artificial intelligence, machine learning, and the whole idea of having a like a digital twin of a watershed or a coastal region. Third one on the list is better monitoring. So here we have things like Earth observation, distributed sensor networks, and things like citizen science as well. So because these three kind of things, the forecasting, modeling, and monitoring, they can be brought together and integrated in kind of decisions support tools for evidence-based watershed and shoreline management. Another key technical solution can be brought to bear, I would call kind of natural and nature-based infrastructure for flood and erosion risk management. So not only can these types of infrastructure kind of help to reduce the risk of flood and erosion, but they could bring a lot of societal and environmental co-benefits along with them. We have solutions, and we need to apply them for how to strengthen older infrastructure, and that may include kind of hybrid green-gray or gray-green solutions. And another key technology we can bring to bear would be developing new guidelines, codes and standards, promoting sustainable and resilient design and risk management. Okay, so next I'd like to highlight some of the research that we're doing here at the NRC to kind of apply some of these new technologies. So the first one I'll highlight is climate change risk in information systems. So here we're really developing tools to predict the impacts of climate change on future ice conditions, wave conditions, storm surges, and water levels in different regions of the country. And then this we're going to deliver, or in the process of delivering this kind of information through systems that enable, I guess, stakeholders to use this information to support informed adaptation planning. So this work involves like high resolution forecasting of future climates, detailed numerical modeling, statistical analysis, and as I said, the development of these digital information systems. The next area of research I want to highlight is a project we call Coastal Flood Risk Canada. So this is focused on helping coastal communities understand flood risks due to things like sea level rise, storm surges, and tsunamis, and to make informed decisions about how to mitigate and adapt to these challenges and hazards. So the key outputs from this will be the development of new regional storm surge and tsunami hazard data sets, and the end goal really to establish best practices for this type of work and develop a national guideline for coastal flood risk assessments. Another area of research I want to highlight is nature-based infrastructure for flood and erosion risk reduction. So here we're working to address some of the key knowledge gaps that currently restrict the use of nature-based infrastructure for flood and erosion risk management in Canada. So this work involves field monitoring at sites where this type of infrastructure has been deployed in Canada, digital twins and numerical development of numerical design tools. We're doing experiments in our labs at the NRC. And we're doing all this to try to develop design guidance for these types of natural infrastructure, and also demonstrate how nature-based approaches can be deployed to, I guess, help control and reduce flood and erosion risk, but also maximize societal and environmental benefits also. Another area of research I want to highlight is work to develop resilient and sustainable shorelines and infrastructure. So here it's about really ensuring that managed shorelines and new coastal and port infrastructure, as well as repairs to older structures, are sustainable, resilient, and ready to withstand the extremes that the future climate will bring. So often this work involves scale model tests in our labs at NRC to loads, optimize designs, and improve performance of these infrastructure, and also reduce overall costs. Another area of research I want to highlight is the whole area of flood prediction and modeling. So improving our capability to predict and forecast floods, using these tools to assess options to reduce the impact of floods, and then support informed decision making. So this includes things like flood forecasting systems, high resolution flood modeling, looking at different options to reduce flood impacts. So things like scenario planning and analysis, and also looking to the future and climate change impacts and adaptation. I think the last area of research I want to highlight is what field we call ice hazard management. So this is a whole kind of body of research to improve capabilities to predict and manage ice hazards in rivers, lakes, and oceans along the coasts of Canada. So this includes things like an ice forecasting model, iceberg drift model, high resolution ice dynamics model, experiments in scale experiments in ice tanks which the NRC operates. And recently we're looking to apply artificial intelligence and machine learning methods to enhance ice forecasting. We're looking to develop coupled hydrodynamics and ice dynamics models. And we're also looking into fragile ice, sort of better understand fragile ice and look to ways of how to reduce its harmful impacts. As we know, ice fragile can block water intakes of all types and can also lead to ice jams in rivers as well. So feel I'm going quite fast through all this, but so let's look to the future. So in 10 years time, sort of I would like to live, and I would like our all our children to kind of live in a Canada where we see Canadian researchers and industry and governments work together to improve resilience to extreme weather and climate change across Canada. I'd like to see a future where climate change impacts on flood and drought and erosion and storm surge and coastal waves and ice hazards. All these impacts are across Canada are understood and then widely used to inform risk reduction and adaptation planning. I'd like to see a world where, improved modeling and prediction capabilities help communities, governments, and industries manage and mitigate weather and climate risks and improve resilience. I'd like to see a future where improved flood forecasting capabilities help communities and governments prepare for disasters and reduce their impact. I've got a few more here, so I'm looking to a future where climate resilient, sustainable design and risk management practices are built into Canadian codes and standards. I'd like to see a future where governments and industries implement nature-based infrastructure solutions to manage flood and erosion risks and realize these environmental benefits. Canadian communities, governments, and industries have the knowledge and tools they need to mitigate and manage flood and erosion risks and adapt to climate change. I'd like to see a future where northern communities are successfully adapting to climate change and are prospering. And lastly, but not least, I want to see a future where the health and diversity of coastal and riverine ecosystems is improving across Canada. So that brings me to the end of my kind of brief tour through challenges and opportunities. So I'd like to thank you very much.
Thank you, Andrew.
Let me unshare here.